Hi guys, in the last lesson we learned about real numbers and their properties, but what do you do with real numbers? Well, in algebra, one thing you do is you use real numbers to build algebraic expressions. Those expressions are then used to solve problems, perhaps model something in the real world. So we're going to look at algebraic expressions. So one of the first things we want to do is make sure we know the difference between an expression and an equation. They're very different, completely different things. And they both start with E, sometimes can be confusing, we can forget. So let's get it straight. Notice that an expression has no equal sign. That's the easiest way to tell right off that it's not an equation. Every equation has an equal sign. So, for example, 7x is an expression. 7x equals 1 is an equation. And we have another example, 7x plus 7x squared. It's just an expression. 7x plus 7x squared equals 1. That's an equation. Equation expresses the relationship between the two sides. It says they're equal. An expression is just an expression. Okay, no, it does not stipulate any relationship to anything. It doesn't say this is greater than something or less than something or equal to something. Just an expression. Okay, so that's important to remember. Okay, so important vocabulary. Get this down pat so that as we go, everything will make a lot more sense. You don't want to be fuzzy on what these terms mean. You don't want to hear about evaluating things and not really know what it is. We're going to be talking about terms a lot as we go through the course, so you really need to know what these all mean. So, evaluate just means substitute a number for each variable, then simplify. Okay? So you probably have an idea what variable means, but it's important that we nail that down. What is a variable? Well, a variable is just a symbol that can represent a number, and it can take on different values. That's why you call it variable. It can vary. It can take different values. So, for example, this x up here in this expression, 7x, x can take various values. It's a variable. Okay? Okay, so evaluate means we're going to substitute a number in for each variable and actually then simplify it to get a value. See what it works out to, basically. Okay? For example, we should look at one real quick. Again, a simple example, this 7x right here. Let it say we put in a 2 for the x. We could then evaluate that. Okay, we would substitute the 2 for the x and evaluate it. 7 times 2 is 14. So the expression 7x evaluated for x equals 2 is 14. Okay, next is term. That's just an expression that is a number, a variable, or a product of a number and variables. Terms are separated by plus and minus signs. Okay, so again, looking at our examples, we have an expression here, 7x plus 7x squared, right there. Okay? That is an expression. How many terms does it have? Well, a term is an expression that is a number, a variable, or product of a number and variable separated by plus and minus signs. So 7x is a term, right? Because that's a product of a number and variable. 7x squared is also a product of a number and variables. There's x squared there. You could think of that as a couple of x's, right? X times x. And those two terms are separated by a plus sign. So you have two terms there. 7x is a term, 7x squared is a term. Keyword in the definition of term is, I think, product. Okay? It's something times something, but a term is not a sum. Terms are separated by plus and minus sign. If you try to say this entire thing, 7x plus 7x squared, is a term, that's just completely wrong. Terms only have multiplication in them, okay? Okay. A single variable by itself, even if it's not multiplied by anything, is a term. A single number by itself is also a term. Of course, think about it. A single variable by itself, like y, you could always think of that as multiplied by 1, right? So it's still a product. When you have something sitting by itself, like 3, okay, that's a product. You can think of it as a product because it's 3 times 1. You just don't write that down, but you could. So keyword is product. Okay, so that's a term. Coefficient is the numerical factor of a term. For example, in this term, 7x, the coefficient is the numerical factor, which is 7. Remember what a factor is? A factor is just one of the things that is multiplied by something. So 7 is multiplied by x. 7 times x is this term. 7 is a factor. X is a factor. Okay? One of the things that's multiplied. Each of the things is a factor. The numerical factor is the one that's the coefficient. In this case, 7. Okay? So get these terms down. Like terms have the same variables raised to the same power. Any terms that have the same variables raised to the same power, they're called like terms. So we have some like terms in this example. 7x is the first term. Are there any other terms that have the same variable raised to the same power? Yeah. 8x happens to be right next to it. Even if the 8x was over here somewhere, it would still be a like term. So 7x, we'll put a single line under them to show they are like terms. 7x and 8x. Okay, so 7x squared, does it have a like term? Is there any other term that has the same variable raised to the same powers? Well, the power there that the variable is raised to is 2. None of these others have that power, right? They're different. They have x to the 4th or x to the 5th. There is no like term for that one. 6x to the 4th, there is a like term for it. We'll put a double line under those to show they're like terms. Okay, 6x to the 4th and 9x to the 4th. 8x to the 5th does not have a like term. So there's a couple of pairs of like terms in that one. A constant term is a term with no variable. Very simple. Remember, terms don't have to have a variable. A term is an expression that is a number, a variable, or a product of number and variable. So it could be just a number. That's one of the possibilities. A number, a variable, or a product of a number and variables, separated by plus and minus signs. Constant term is just a term with no variable. Okay? So, scroll on down. We do not have a constant term in this expression here. We could put one in, why don't we? If we've had plus 5 at the end, that would be a constant term. Okay. I'm going to scroll this down. So let's look at some things we do with expressions. We've got some definitions. We understand how to talk about expressions. You know, what do you use them for? And one thing you can do is modeling words with an algebraic expression. So we have 7 fewer than a number t. We want to model that with an algebraic expression. 7 fewer than a number t. So which of these is it? Give you a moment to look. 7 fewer than a number t. Okay. Well, this one says t plus 7. That sounds like that expresses something that's bigger than t, right? T plus 7 is bigger than t. We want to express 7 fewer. Negative 7 times t, that has a negative 7 and it has a minus sign. Fewer sounds like minus, but this multiplies that negative 7 times t. That's not going to get us 7 fewer. Here we have t minus 7. And here we have 7 minus t. I think it's one of those. Which one is it? Well, we want something that's fewer than t by 7. That's t minus 7 would get us there, right? That is 7 fewer than t. You start with t and you subtract 7, then you are 7 fewer than t. Okay, next one. 2 times the sum of a and b. This is a little bit longer. I like to read these from right to left and then write the expression as we go. So let's just read it right to left and try this. 2, okay, 2. 2 times something, okay, 2 times something. We can say 2 times. 2 times the sum. Oh, 2 times the sum. You just read it right to left and fill stuff in. 2 times the sum, well, we can write a sum. We don't know what the sum of. But if we write parentheses and write a plus in the middle, that's a sum. So all we've done is read this left to right and filled in some symbols in the place they go. The symbols don't go right to left, right? We're going to come back and fill in some symbols in here. But we read from left to right. 2 times the sum. Sum of what? Sum of a and b. Okay, the sum of a and b just means the a goes there, b goes there. That's now the sum of a and b. So that looks like that's it. Here it is. It's number C is our choice. Okay. So you can model words with an algebraic expression. You can model a situation. That's our next example. I'm having a hard time with this scrolling. Okay, so the situation is you start with $20, you save $6 each week. And we just want an expression to model that situation. We're not solving a problem yet. This might be part of a problem, but for now, we just want to model that situation. So, the idea is the expression that will show how much money we have at some point in time is the starting amount of money plus the amount we save per week times the number of weeks, right? The amount saved per week times the number of weeks. So if W is the number of weeks, 20 we started with plus 6 times W, because 6 is how much we save each week. So 6 times W, with W is the number of weeks, will give us the total amount we saved, and then that's added to the 20 we started with. Okay, so the next example is evaluating algebraic expressions. This is what we talked about a while ago. Evaluating just means you plug in an actual number for the variables, and then you simplify it. So let's do this. 7 times a plus 4, but we're going to evaluate that for a equals negative 4. So instead of writing a, we're going to write in the negative 4. And then that's plus 4 plus 3b and we have a value for b, right? They want us to evaluate it for a is -4 and b is 5. So we put in a 5 for the b. And now it's -8. So we just evaluate. -4 plus 4 is 0. That's kind of handy. So 7 times 0 is 0, and we have 15 minus 8, and that is 7. So evaluate that expression for those variable values. Comes out to 7. Okay, combining like terms. In an expression, you can one of the steps of simplifying is combining like terms. If like terms have the same variable raised to the same power. So here we have like terms, 5a and a. Those are like terms because the variable's the same. It's a. The power is the same. There's no exponent, so it's raised to the power of 1. 5a minus a is 4a. You could think of it as saying 5 A's. 5 times A means that's how many A's you have, right? There's 5 of them. And you're subtracting A. You're subtracting a single A from those 5 A's. You're left with 4 of them. Okay, negative 5A minus 4A. Bunch of negative signs there. If that gives you trouble, I kind of like to change subtraction into addition to make everything a little more clear. So we could say negative 5a. Instead of minus 4a, say plus a negative 4a. And this is a little trick to clarify things. Right, I'm just writing it a little bit better. Plus a negative 4a. Because now we have a negative plus a negative, so it's just going to go farther left on the number line, right? If it's already negative 5, then we're adding negative 4 to that, ends up negative 9, and negative 9a. Okay, so the next one, we want to combine like terms. We have two terms that have r as the variable, correct? 6r and 4r. We combine those to 10r. And the 3s and 2s, they have the same variable, s. 3s plus 2s, 5s. Okay, and the last one, 7b squared plus a squared plus 3a squared minus 6b squared. Be a little careful with this one. 7b squared. Okay, the like term for that, the only one is this negative 6b squared, right? They have the same variable to the same power. These others have different variables or different powers. So that is b squared. A squared. A squared and 3a squared are like terms, right? So that's 4a squared. And I think that's, well, we can't just get, the negative 6b doesn't disappear. It's still there. It has nothing to combine with it. There are no other like terms for it. So you just write it down, leave it just how it was. And I think we got it. 7b squared. Sometimes what people do at this is cross them off as you go. I'll just kind of underline them. 7b squared, negative 6b squared. We got that. We took care of that term. We took care of these, and we got our 4a squared, and the negative 6b, we took care of it also. That way, you could cross them out is another way to do it, and make sure you've accounted for everything. Okay, so that's it. Here's the homework assignment. That's also in Canvas, and you go to Canvas to get the textbook. So that's all for now. See you later.